Hello, in this video I wanted to use this MATLAB app that I have to illustrate solving row reduction problems. So we had 5, 3, so we can just reduce the number of rows, and let's make the rank equal to 3. Actually, if you just use no requirement, in general it will have the highest rank possible, which is just the number of pivot columns it can have is just the minimum number of rows or columns. So let's just do that. And we're just going to use the row reduction operations. Suppose came from a system of equations, and this was the augmented matrix. So let's just do that. So what do we do here? This right here looks like a good candidate to be our pivot. We just negate this whole row, move it up. So typically we use this 1 to cancel out everything else down here. However, you can use the rows that you have down here to cancel each other. That's going to be really nice for these two because you can just add them. So let's just illustrate that. So if we took this row and added it down, that would be R3. It's going to be replaced with R3 plus R4. So we'd be adding down, so we get 0, adding down, we get 1, adding down, we get 5. So this should be our new R3. So let's do that. That's what we get here. Okay, so now that we can't really use the 3 and the 4 really to cancel each other out, because that would involve dividing by 4 and then multiplying by 3. So let's just use this 1 here. That would just involve, let me actually at least write the stuff we're going to be using. So we do R2 is going to be replaced with R2 minus 4R1. So what is, I can just, let's just do this first one, 4R1. What is that? That's negative 4, negative 16, then 12. And that's going to be added to this. Get our new row. So adding this, we get 0, just like we wanted. And here we get negative 11. This we get 12. So let's do that step 1, and we used to get rid of the 4. That's what we have here. So let's create that. You can also use the 1 to get rid of this by adding 3 copies of R1 down to 4. So now we have that. We have an obvious candidate for our new pivot. So let's move this up. This is going to be our new pivot. So we use this 1 to cancel the 4. So we're going to subtract 4 copies. So we minusing 4. And let's just use the app. We can do it all by hand, but we can just use the app, right? 1 here. What you can do is you can take 10 of these and subtract here, 10 of these and subtract here. If you wanted to, you also could just add here, and then you just kind of get a feel for what you want to do. The more systematic way is just to use the 1. You can go through it and do it again. Then we get this. So in terms of row reduction, we're not finished row reducing. However, if we were keeping in mind that this was an augmented matrix, if you're doing that on hand, by hand you would typically have this bar here. What you would see is that you have rows of 0 equaling a non-zero number. So for instance, this equation right here, this line, this row, tells you x, 0x plus 0y is negative 55. So that just tells you that negative 55 is equal to 0. And that's a contradiction. So it tells us that this system of equations that we were trying to solve earlier didn't have a solution. There's no solution. So if we want to put it in row reduced echelon form, we could just turn this into a 1, use it to get rid of this. That's row reduced, and then you continue. However, this is row reduced echelon form. However, we didn't need to do that if we were trying to solve a system of equations and it was an augmented matrix. We had the bar down the middle. Because once you had zeros, once you had a row of zeros here, like let me just write it again. So we just did row reduced echelon form. You still see the contradiction. Zeros equals 1, so it's 0 equals 1. It's a different contradiction. This is 0 equals 0. That's perfectly fine. That just tells you one of the equations is redundant. This tells you that one of the equations is contradictory. So this is 0 equals 0, this bottom row here. But this row says that 0 equals 1, which is just a contradiction. So what we typically say is that the system is inconsistent. The system is inconsistent, so what that tells you that there's no solution. Okay, so what do we have? Let's actually start over. And you can do the same thing. Instead of using the 4 to get rid of the 4, we can just go right away and turn this into a pivot. Cancel these things out. And here you still get a contradiction. This was an augmented matrix like this. And we'd have 0 equals 67 over 11. So we still get a contradiction. If you solve it a different way, you just get a different contradiction. Okay, so that is example that I wanted to do. Hope you have a nice day.